Hi guys, today we're going to be going over our last lesson in this final topic of solving quadratic functions. And this lesson is going to be a little different than some of the other lessons that we've done so far. So far in this topic we've talked about different ways that we can solve a quadratic. Some of the ways that we used are here in our table of contents. We used graphs and tables. We then talked about how to solve by factoring. We learned about rewriting radical expressions so that when we got into solving quadratics using the square root, we were able to simplify those radical expressions within those solutions. We learned to complete the square, and then finally we learned how to use the quadratic formula. Today we're kind of shifting gears and we're going to talk about solving a system of linear and quadratic equations. So if you could just title this page Systems of Linear and Quadratic Equations. As I'm going through the video, please feel free to stop, pause, rewind as you need so that you can best understand what it is that we're learning today. So first thing we're going to be talking about is, well, what is this system of linear and quadratic equations? So a linear and quadratic system is of equations includes a linear equation, so something that's probably in the format of y equals mx plus b, and a quadratic. Okay, and they could be represented in different ways. I know quadratic equations can be written in a couple of different forms. So as long as it is represented by a quadratic where you have x squared, this is going to be a system of a linear and quadratic equation. When I'm looking at the solution to a system of linear and quadratic equations, we're looking at, just like with a system of regular linear equations, you're looking at where they intersect. We're going to be doing the exact same thing here. So it says the graphs below of a line and three parabolas show that lines can intersect a parabola at 0, 1, or 2 points. Now this doesn't have the graphs, but we're going to create them. So the first, we're going to draw 3 coordinate grids so that we can represent each of these situations. And then you'll see what it looks like to have 1, 0, 1, or 2 solutions for these types of systems. All right, so if I were to draw a parabola, and let's just say that the parabola is just maybe just our parent function here. I'm going to draw that same parabola on all 3 of my coordinate planes. Something that has no solution would be if I had a linear equation that went along with this quadratic that looked something like this. You can see it never passes through the parabola, so that right there is a really good example of something that has no solution. Okay. One where there is one solution is if I have a line that just grazes the parabola. So it might graze it right here at this point. That's going to have one solution. And then something that has 2 solutions, it's just a line that crosses through at least 2, well, not at least, exactly 2 points of that parabola. So this is going to have 2 solutions. So when you approach a problem like that, you're definitely going to want to say, before you even start, does it have a solution? And then if it does, how many solutions does it have? Just based on what it looks like after you graph it. So we can use graphs to find the solution of a system of linear and quadratic equations. So if I have the problem, it says, how can you use graphs to find the solutions of the equation 5 minus x squared equals x minus 3? Now you can see I've got a quadratic on one side of this equation and then a linear equation on the other. We are going to set each side of the equations equal to y to start. So you can see the first equation, which is our quadratic, 5 minus x squared, right here is set to y. Maybe I can color coordinate this. That's one part of it. And then we have the other part, which is your linear equation x plus 3. And I know it's linear because the x doesn't have a exponent. Okay, then what I'm going to do is I'm going to graph the equations on the same coordinate plane. Now, we just learned how to graph a parabola. Just a refresher on how to graph a linear equation. You're going to first plot the y-intercept and then use the slope, which is the coefficient of x, to figure out how far up and how far over you're going. So since this doesn't have a coefficient, it has that invisible 1. That means our slope is 1 over 1. Connect the points. That's how I would graph. Now, once I've graphed it, I can visualize where they intersect. You can see that they both pass through the point -2, 1, and it also passes through 1, 4. Okay? Once you've done that, you always want to make sure that you can check your solution. So since these are my two solutions, I'm going to see that if I were to plug in each of the points, that it is true. So for my first equation, 5 minus x squared or I guess it's with them both together, equals x plus 3. If I plug in the first point, 1 for x, I should get a balanced equation. Oh, I should get a balanced equation. The second one, if I were to plug in -2 for x, I should also get a balanced equation. So we know that the solutions of the equation in this case are x equals 1 and x equals -2. They both work. Now, just like when we were solving for regular quadratics, I'm just looking for x. And the reason why is because if I look back at my equations, I don't really have a y value. I'm looking at just solving for x. So that's how I solve a system of linear and quadratic equations.